Okay, so the recording is started. So we are still doing the examples of mapreduce, that is Hadoop on Windows. And so in the previous class we have made these things. So we have done a word count, simple word count, just like to understand how to do the things in Eclipse, and then we have renaming part files. Then we have done the custom partitioner basically. So today we see few joins, and I will show you one image processing basically. So we need to put some images in HDFS and try to find out that how many of them are duplicates basically. So or to prevent duplication or to avoid the duplicates and pick only the unique ones. Okay, so that particular use case is very useful in case of like if you're doing some medical use cases wherein there are a lot of images from MRI or CT scan. Okay, and then even on your local WhatsApp or sometimes like you are like the part of multiple groups in your WhatsApp, and then you have like a few thousands of images basically. And suppose if you want to delete or if you want to keep only the unique ones, so this kind of algorithm or this these case you can put all your WhatsApp data into HDFS, do the unique site kind of selection, and then again put it back into your WhatsApp folder. That's the best use case you can you will use this. You can use this okay, directly on your Android phone, uh, or you can develop an app. Okay, yeah, but then again, it would be like a normal utility if you run it on Android as a app. But then, if you are having your Hadoop ready on your Windows, you just copy all your WhatsApp photo into some folder and then copy it into HTFS and then run this algorithm, and then again copy it back to your Android WhatsApp folder. So it will give you only unique ones. Okay, so these are some like no things you can use. Uh, so let's uh, So there are two type joins we already know. One is website join and one is reducer join. The problem with the website join currently in my system is that it is not supporting the file system of Windows. See, the thing is, what happens is whenever this Hadoop started designing, right? So whenever they started designing Hadoop, they kept in the mind that it needs to be run for most of the cases on Linux file system only, or like because HDFS file system basically runs on the Linux file system. So uh, they kept in the mind only Linux working model in mind, and when they started designing the Hadoop. So most of the cases where this Linux and uh, in Windows are working differently in their core features, there Hadoop sometimes gives problem to do the same thing on the Windows that it actually does very easily on Linux. Okay, so the map side join is one of the use cases, but I still have the code that one of my one or two which is prior student Ashish, he has made it run on Windows as well. And he yesterday only he shared the code with me, so I will just forward that it to you. And when you start practicing this kind of try this and map surgeon, try it his solution and see if you will be able to run the website join without any problem on Windows as well. Okay, we'll try today also. I will copy and paste his code and see. So the thing is, we need to actually, I mean, there is an option to provide the file system also that on which you want to perform the MapReduce. Okay, so most of the time it is by default Linux or HDFS file system, but here in Windows we can also try to fix the file system and see if it runs or not. Okay, so we will start with reduce site join because it's simpler one, and then we will go to website join, and then finally we will do the you know that image processing use case. So that will that will give us a confidence that yeah, so it's not only the text data that we can easily do the processing on, but image data also. So so this is like kind of extremes cases, right? So at the one side we have been working with the text input format, and then other side we are actually working on the binary input format. Okay, so in between like audio data or any other like sensor data, whatever format you are having, it's like kind of data only, right? So you just can put an HDFS, have some correct survey for it, or like any correct input format for it, and then you will be able to process it. Okay, so this is reduced side join. Okay, so reduced side join and map side join. So differences what are there? So basically reduced side join. Let's say if you want to join two files, okay, or two data sets basically. So every data set, maybe suppose if it is suppose if they are like smaller than the block size, so it means for one block one input is pretty equal to one map, right? So it means like suppose if there are two files, those are like even smaller than the block. So two mappers will run. Okay, they both will generate the key value pairs as output of their run. Okay, so now what the shuffle and short phase will do, it will combine, so it will generate a single key but then list of values. So that list of values will be the values coming out of both the maps. So let's say if map 1 has generated 3 values for that particular key and map 2 has generated 2 values for that particular key. So in the shuffle short phase work or to the input of the reducer, it will be like a key and 5 list of values. Okay, so then reducer just needs to iterate over the list of the values and do the things that you want it to do basically. Okay, so it's very simple. So you need to have two mappers and one reducer. It means that you need to have two input file for input path. Okay, how come? Because because the files are on different location basically in HDFS. So let's say in different directory, two different directories, the files are there that you want to join them and produce a result. So two input parameters would be the input paths of both the directories, so path 1 and path 2, and the final path would be where you want to put the output result. Okay, so that's how we can do the things. Now let's have this first name data set and the last name data set. Okay, so we need to join them, join in such a way that we should get the first name and last name in the output. Okay, so problem statement join both the data set by applying reduce search join and have full name in the result file. Okay, so now you can have key as well as a part of your data, not a property. It should appear in the output like big data Hadoop. Then second name should be Databricks Spark. Then third name should be streaming Storm and like that. Okay, so let's do that. So I will create a class that I will call reduce, or you can say join job. Let's go through the okay. So first thing we need to define the handling of the logs of this program so that we can see something on screen while we run the job. So it should be private static final log type log that is equal to log factory dot get log for this class. Import the log. Okay, if args dot length not equal to 3 this time. Why? Because we need to provide 3 parameters. 2 parameters are for 2 different directories of input and 1 parameter is for the output. Okay. Now we can say syso the parameters should be 3 for reduce side join. We can also generate log.fatal. And finally do system exit. Okay. Then we should have define job is equal to new job. Then define import job. It should not from here. It's not giving warning because I think this is deprecated. Add suppress warning to job. Okay, that's it. Now file input format dot add input path. So this is the first for job and new path. Provide args. The first, this is first input path. The first input directory. New path. Okay, so file input format might be coming from different thing. It should be from here. Unhandled exception, so just state it. Okay, now let's copy copy the same thing, and this time we will have the second argument as the second input directory, and should have file output format. Set output path. Okay, now this is done. Now I should say saw job set jar by class job set job name say reuse site join job dot set. Okay, so here we see multiple outputs, so I think we need to change few of the things. So this is done, this is done. Okay, multiple inputs instead of file input format, we need to use multiple input. Okay, so that we can define multiple input paths. Just remove this and define multiple inputs dot add input path, because we also need to provide that what would be the input format type and who will handle it. Okay, so that particular directory, which mapper will handle it. Okay, so that information we need to provide one after the other. So job path and input format class. So basically there are how many parameters? 1, 2, 3 and 4. Here we need to take that constructor that is having 4 parameters. So 8 path input format mapper to the list of the input. So this is what we require. So job new path so this is the input directory. Then input format class is our text input format. Yes, yes, we can have that. Oh, sorry, text input format dot class. Yeah. Mm-hmm. Okay, so we need not to define again the mapper, just like job set mapper dot class over here. Why? Because we already defined in multiple input that which mappers we are going to use. So we just need to provide that which reducer class we are going to use. Okay, so file output format set output path. This is done. Set job by class job name set reducer class. So we are saying it as join a reducer class. Then we can define the number of mapper, job set, number of tasks, let's say 1 in this case. Then job set map output key class and map output value class that is needed. Okay, so we are joining both the text as a first name and last name, so we just set that set map output key class would be text.class and job set map output value class also would be text. Then at final say system dot exit and job dot wait for completion. If it is true, 0 else 1. So this is to be our job configuration. I now write mapper 1. Extends mapper we are going to provide it text and we are getting out with text only. Let's have that. Import it. Then we do have setup, we do have map, clean up. These 3 methods, you can do whatever you want with them. Mostly we will work with this one, key value and context type context. What we are going to do is, sorry, this is long right table. What I'm doing. This text and then it in map output will be text. Okay. Now what we are going to do is let's read it and emit the text out of it. Okay, so what we are going to do is let's have key. So just create a string of words. Okay, and read the value dot to string, and then you can say this is line, and define a string array for words that is line dot split. Split the string width tab character, right? We do have tab as the data. So you can have comma separated also, but this time I'm just trying to show that how to use a tab delimited data in processing. So let's copy them first name kind of thing, or maybe I'm having it, not having. Okay, and also create second name. And the same data set we are trying to use in website join as well. See, the thing is why I'm showing this method research in Java. Actually, sometimes you may be asked to write in an interview that just write a website join. Okay, so they will play a trick just to know that whether you have done or you know it or not. Okay, but if you've done it, you'll be selected. Okay, that's why I'm just like emphasizing that do the practice. I know that Hive is quite simpler to do this kind of such joins. Even in the production, you will never write such kind of code in your entire lifetime in Hadoop in order to do the mapreduce join. Okay, but the thing is, it is like interview trick. They will give you pen and paper and at least try ask you to write algorithm. Okay, they won't expect you to write a full code like this, but at least you should know that which classes should be used and how to do the algorithm, and that's it. Again, once you show it, that's it. I mean, there would not be the second question in MapReduce or any other thing, and like that would be the key to success. Okay, most of the guys who learn it from somewhere or maybe not, I'm not sure, but they are not at all, will be like able to write such kind of things, okay, on plain paper. So this will, I mean, you just like, at least all this, whatever we've done in our class, all these 8 to 10 things, okay, few of them, you can easily show them that this is what the challenges you face and how you resolve it, just like part file naming and this image processing. So image processing, very simple. I mean, it's not like that tough, you can say use case. Yeah, but still you can, use it, or at least can tell them that how the image processing can be done by using byte writables. Okay, now once we have words, let me stop recording what it says.